Welcome to our video, Can Space Junk Fall on Your Head? An in-depth exploration. Today, we'll take you on a journey through the fascinating and often alarming world of space debris. We'll uncover what space junk really is, how it travels back to Earth, and the potential risks it poses to humanity. From notable incidents of falling debris to the environmental impacts of re-entry, we'll also discuss international efforts to manage this growing threat, including the dangers posed by megaconstellations and the Kessler syndrome. Join us as we explore this pressing issue and consider what the future holds for space safety. 1. Understanding space junk. Space junk, or space debris, refers to the vast collection of defunct human-made objects that orbit our planet without serving any useful purpose. This includes everything from decommissioned satellites and spent rocket stages to fragments created from previous collisions. According to the European Space Agency, ESA, as of September 2024, there are over 40,000 tracked debris objects larger than 10 centimeters circling Earth. These objects, traveling at high velocities, pose potential risks not only to operational spacecraft but also, occasionally, to life on our planet. Imagine a junkyard in space with bits and pieces flying around at unimaginable speeds. The dynamic nature of space junk makes it a topic of concern for scientists and space agencies worldwide. 2. The journey of space debris back to Earth. Most space debris remains in orbit for extended periods, slowly descending due to atmospheric drag. While smaller debris typically burns up upon re-entry, posing minimal threat, larger objects can survive and reach the Earth's surface. NASA has reported that, on average, one cataloged piece of debris has fallen back to Earth each day over the past 50 years. It's a bit like the old saying, what goes up must come down, but in this case, it's more about how and when it comes down. The unpredictability of re-entry paths makes it difficult to determine where these objects might land, adding an element of surprise to the situation. 3. Assessing the risk to humans. When it comes to the risk of space debris causing injury or death, the odds are extremely low. Estimates suggest that the chance of space debris hitting someone is in the 1 in 10,000 range. To date, there have been no confirmed fatalities attributed to falling space debris. Think of it as being struck by lightning or winning a lottery, improbable, yet not impossible. However, with the increasing number of satellites and space missions, the potential risk does grow, much like increasing traffic on a busy highway raises the chances of an accident. 4. Notable incidents of falling debris. Though rare, there have been instances where space debris has reached populated areas. In March 2024, a 0.7 kilograms piece from the International Space Station, ISS, impacted a house in Naples, Florida, causing damage but no injuries. More recently, in December 2024, a large metallic ring, believed to be a rocket separation ring, landed near Mukuku, Kenya. These incidents highlight the unpredictable nature of re-entering space debris. It's like finding a needle in a haystack, except sometimes the needle finds you. 5. The growing concern of megaconstellations. The deployment of megaconstellations, such as SpaceX's Starlink, has led to a significant increase in the number of satellites in low Earth orbit. As of 2021, there were more than 4,000 satellites in orbit, with projections estimating over 100,000 new spacecraft to be launched by 2030. This surge raises concerns about the potential for increased space debris and the associated risks. Imagine a crowded freeway in the sky, with each satellite representing a vehicle. The more vehicles, the higher the chance of collisions and subsequent debris creation. 6. Environmental impact of re-entry. Beyond the immediate risk of debris impact, the re-entry of space junk contributes to atmospheric pollution. A global inventory cataloged the air pollution from space activities between 2020 and 2022, noting that 446 rocket launches and the re-entries of 3,622 objects resulted in approximately 12,000 tons of pollution. Pollutants include soot, aluminum oxides, and other particulates that can have long-term environmental effects. It's akin to having a bonfire in the sky, where the smoke doesn't just disappear but lingers, affecting the atmosphere. 7. International efforts to mitigate space debris. Recognizing the growing threat, international space agencies are taking steps to address space debris. The European Space Agency, ESA, has initiated the Zero Debris Charter, aiming to halt the creation of new space debris by 2030. Additionally, missions like ClearSpace One are being developed to actively remove defunct satellites from orbit. These efforts are similar to organizing a large-scale cleanup operation, akin to clearing litter from a park to ensure its safety and usability for future generations. 8. The Kessler Syndrome. A cascading threat. The Kessler syndrome posits that as the density of objects in low Earth orbit increases, the likelihood of collisions rises, potentially leading to a cascade of debris generation. This scenario could render certain orbital regions unusable and significantly impact satellite operations. It's like a domino effect in space, where one collision triggers another, creating a chain reaction of debris that could eventually block paths for future space missions. 9. Recent developments and incidents. In recent months, there have been notable incidents underscoring the space debris issue. In December 2024, a derelict Chinese satellite re-entered Earth's atmosphere, creating a massive fireball observed across the southern United States. Such events highlight the unpredictable nature of space debris re-entry and the importance of monitoring and mitigation efforts. It's a reminder that while these events are rare, their impact can be significant, drawing attention from communities and scientists alike. 10. Future outlook and safety measures. As space exploration and satellite deployments continue to grow, so does the importance of implementing effective space debris mitigation strategies. This includes designing satellites for controlled re-entry, developing debris removal technologies, and establishing international guidelines for responsible space operations. Public awareness and international collaboration will be crucial in ensuring the long-term sustainability of space activities. It's much like setting traffic rules for the skies to ensure that everyone gets to their destination safely without causing harm to others.